So this section is all about transforming the data so that you can end up with more linear scatter plots and be able to predict better. So we're going to be able to use powers or logs is to be able to get there. So for example, we might take whatever our data is and square it. We might take whatever our data is and square root it. We might take our data and raise it to a negative exponent, which would be reciprocal of it. So all of these are different avenues and ways that we could transform the data so that it will look more linear. And then, again, we'll be able to predict a little bit better, because all of this is going to be reviewing the least squares regression line, which is all about predicting what will happen with the data. Another thing that we'll be able to do is predicting using logs. It doesn't matter if we're taking the natural log of something or the base 10 log of something. And we might be able to take it of both sides, of just one side. We're going to try different combinations to see what will work. So if you read through this question, it says, what does a country's mortality rate for children under 5 years of age per 1,000 live births tell us about the income per person, measured in gross domestic product per person, adjusted for differences in purchasing power for residents of that country? Here are the data for the random sample of 14 countries in 2009, and I've given the data there. So the very first thing that I want you to do is put this in your calculator and then unpause. So you should have your child column filled in, and your, I'm putting child like for the mortality rate. Income I have over here in my column, or my column for part B, or for B. And I'm going to make a scatter plot of it and see what the data looks like, because the goal is to make this look more linear. So when you look at this data, to me, it looks curved. It definitely looks like it's on a curve. So we can transform the data, but we don't really know what to do just yet. What will make it more linear? So you have a couple options, and we can try doing all different ways to transform the data. So I'm going to put child T for child with a transformation. If you put equals in this column right here, this is like an Excel spreadsheet. So if I put child, notice it bolds. That's taking the child column, and I'm going to square it and see what happens. I'm going to do income T, which means the transformation of the income, and I'm going to square that as well. And just take a look at what that scatter plot, if it changes at all. So when I look at the scatter plot, it originally was curved. If I had the transformed child, to me it still looks curved. Transform both, still looks curved. Go back and only transform one, it's still curved. It doesn't look like a straight line to me at all. So maybe I'll try something else. I'll put equals the square root, or the 1/2 power. And this says, will you overwrite the data? I want to overwrite the data, yes. So I could put it as a power of a half, or I could also write it like this, where it's square root of the income, or square root of the child. So now I've got new transformed data. You got to go back in and redo it. Transform child to regular income. Look to me curved. This is still looking curved when I've got them both transformed. Just income transformed, it's still looking curved. So let's try something different. Let's try doing the reciprocal. And you can put that to the -1 power. That would be a reciprocal. Yes, we want to overwrite the data. Or you can put it 1 over income, or 1 over child. That will get the same exact results. And let's see what happens when we do the reciprocal. Remember, the goal is we're trying to change this so it becomes linear. So this is what the original looked like. Transforming just the child. Definitely is looking more linear. Transforming both, no, it's back to being curved again. Transforming just income, again, looks a little linear. So we already have one spot now where we have this to be where we are making it a little bit more linear. So now I'm going to put a regression line in there. Okay, and we'll jot this down in a second. This is the one regression line. And this is the other combination. We'll jot this down as well. And that will be our least squares regression lines that we'll use. So when we go to that, we transform the data. Transformation number 1 was the reciprocal of the income. If you couldn't see it, this is kind of what it was meaning. The second one was the plain old income, and it was the reciprocal of the child. And these are two linear regressions that will help us predict the data. So if we want to use these to predict 20.3, transformation number 1, we want to put in the mortality rate, the child mortality rate. As 20.3 and do some calculations. When I do this, I get, the tricky part is you end up 1 over the income equals, so I get like this very, very small number, which doesn't seem possible, but remember, that's the reciprocal of the income. So I kind of cross multiply and find out that the income ends up equaling 6,393.86 or 86 cents. When I do the next one, keep in mind it's straight income, and it's a different regression line, 8, 6, 8, 3, 5, 6, 10, 4. And you have to be careful that you put in 1 over 20.3. and do all the calculations. And for this, I'm getting an income, when I did all the calculations, of about $6,034.27. So feel free to do that. In the calculator, we'll want to do 2 variable statistics to see what the R is. So we got to decide what did we compare for each one of these. So I'm going to go to 2 variable statistics. And the first one I'm going to use is where child was regular and it was the transformed income, which was the one with the income is the reciprocal. So this is transformation number 1. And when I scan all the way down, I'm going to get an R of 0.959515. So we'll jot that down. And then we'll try it again, except this time with the child transformation and income plane, and see what the R value is. Ends up being 910837. So when I go back to my paper, the R equals, for transformation number 1, 9599515. If you square that, that will give you your R squared. Square it and it works out to about 92 or 0.92%. Now, in the context of the problem, this is one of the things that we had a difficult time with. It means 92% of the variation in the income, but this is the reciprocal income, is accounted for by the least squares regression line using X as the child mortality rate, or something like that. When we look through transformation number 2, it was an R of 0.918037, which was about an 84% when you square it. So R squared is telling you how, kind of how strong of a connection this is. If you have 90% of the variation accounted for by the least squares regression line, then that's a pretty strong fit line. If you get a 10%, you know it's a very weak connection between those two. So when I look at this one, I've got 84% of the variation. That's probably the worst line, the worst fit. The first one was probably, transformation 1 is probably a better fit for the data. If you look at the residual plots as well, when you go to the graphs, so this is the one, this is transformation 2, which I feel is probably the worst of the two. We'll sketch that below. And remember, it's supposed to be more scattered. If it's more scattered, it's more appropriate. Now be careful when we switch over to the other residual plot, it doesn't actually carry over. You actually have to redo the residual plot for it. That looks a little bit more scattered, a little bit better. So when you take a look at the transformation number 2 for this, it definitely looked a little bit not as nice, but as far as the residual plot for this one, it definitely looked a little bit more scattered. Some here, some there. You don't want there really to be a pattern. You want it to be more of a scattered look. Come back up to this top one. For transformation number 1, we probably would say is probably the better choice. And when you look at it, the income, if we were to predict it, was about there. So that's probably the best choice that we have for now.